So hello students, in this video we shall see some recap or some practice problems, I would say, as part of your preparation for your upcoming UT. Okay, so let's start off with the algebra component. Okay, so we saw an introduction to algebra, and then we talked about terms, the classification, then we talked about degree, polynomials, and so on, all that, right? That was the basic part of algebra. Then that is like you might have studied that in grade 7 as well. Moving on to grade 8, we actually had a little more insight into this. We talked about degree of a polynomial, okay? And then we saw how to classify polynomials based on number of terms and based on degree and all. Then we moved on to operations, that is addition, subtraction, multiplication, and division. We didn't do division. We talked up till here, that is up till multiplication. And then we moved on to identities. Okay. So if you can recall this. And then coming to the identities, we spoke about a plus b the whole square, which is a square plus b square plus 2ab. And a minus b the whole square, it is a square plus b square minus 2ab. Then we talked about a square minus b square, which is a plus b into times a minus b. I told you that you can, omit that sign. So you can, this is not required. It is as good as this. So when there's nothing mentioned, it is multiplication. See, we saw up till here, right? And then we also moved on to a plus 1 upon a the whole square. Okay, this is technically what? If you relate to your a plus b the whole square, your b is the reciprocal of a. Yeah. So b is 1 by a. So it will be a square plus 1 by a square plus 2. And here a square plus 1 by a square. This is a square plus 1 by a plus b square. I'm just trying to relate to this. Okay. Plus 2ab. So because a into b is equal to 1, because a into b is 1 by a, right? So this technically a into b becomes 1 in this case here. That's what is happening there. Okay. Okay. So then what is a minus 1 by a the whole square? That would be a square plus 1 by a square minus 2. Okay. So up till here we have seen, right? Okay. The sequel to this is your multiplication of polynomials. I mean binomials. Like I had expressions like x plus 5 into y plus 3 and so on. So when I'm multiplying binomials, and then beyond this, I went on to identities. Okay, so that's about it. Let's just move on with a few exercise problems. Let's take the example of 104 into 96. See, and the question is, you have to solve using identities. Using identities. So now you can directly solve and you can check your answer that you can do. But since it's mentioned identities, you specifically have to use identities. Right. Because if you don't use identities, you will not get marks. Because 104 into 96, anybody can do who knows multiplication, stage-wise multiplication. We know that, right? So in the first thing you multiply by 6, then you leave a space, then you multiply by 9, and then you add the components. That is simple. That's what you will do. Or you can always cross-check with a calculator. That's not what we're going to do here, because in identities, what we will do is we have to use algebra, isn't it? So if you relate to your algebra, what identity can you think of? I can think of a plus b into a minus b. So how do I break it up into a plus b into a minus b? So 104 and 96. So I can look at the midpoint of both of them as 100, right? So you can say 100 plus 4 and 9, that is 104, and 96 is 100 minus 4. So see, if you relate, this is your A, this is your B. See, A and B. So once you have presented it in this form, then it's very easy. Because what is A plus B into A minus B? It is A square minus B square. So here it will be 100 square minus 4 square. 100 square, of course, is 10,000 minus 4 square is 16. 10,000 minus 16, 9,984 will be the answer. It is quite simple here. Okay. So we can apply this strategy or this, I will not say strategy, rather it's an identity, yeah, for more complex situations. So now we can stick on to this. This is an example problem where you can use identities. So just to recap, what is A plus B into A minus B? It will be A square minus B square. So you can try this out. Suppose I say 103 into 97. So the breakup will be 100 plus 3 into 100 minus 3. Likewise, if I say, let's say, if I say 102 into 98, it will be 100 plus 2 into 100 minus 2. So you see that? So this is how you will bring it to the form A plus B into A minus B. And then you can say A square minus B square. All right. So this is about it. And then you can check, okay, whether you do it with long multiplication or identities. Here, of course, when they ask you identities, please do so with identities. As practice, you can cross-check. Verification can be done in different ways. Let's move on. I'll just go on to another problem from algebra. So A square plus 1, and algebra is very important. Please remember, this is especially, I'm talking about people who are going to take up math stream. Okay, because moving on for your other equations, linear equations, solving, and beyond this, I'm saying, okay, algebra is very important, simultaneous equations and so on. So you have to work on algebra in grade 8, make your algebra basics strong, identities and so on, so that when you come to 9th, it's going to be easy for you. Otherwise, if you can't neglect algebra now. 7th should be the starting stage. So in 7th, you have learned some fundamentals, I suppose. 8th will be an add-on to this. Okay, A square plus 1 by A square is equal to 11. So you have to find A plus 1 over A, and you also have to find A minus 1 over A. So they have given you this, what is the expression, I would say, equation or this data, and using that, you should need to find this and this. It's quite simple. See, if they ask you find A plus 1 by A, start with A plus 1 by A, the whole square. So we've already seen an identity related to this, isn't it? It will be A square plus 1 by A square plus 2. So you just have to plug in the necessary values. A plus 1 by A, the whole square is A square. Okay. By the way, what is A square plus 1 by A square? It's given, right? It's given as 11. 11 plus 2. So A plus 1 by A, the whole square, 11 plus 2 is 13. See now, I told you that if you relate it to that form, P square is equal to Q. This implies P is plus or minus root Q. So likewise, apply the same logic here. A plus 1 by A, the whole square, is equal to 13. P square is equal to Q. P is plus or minus root Q. So what is P? P is this A plus 1 by A, which is what I want, isn't it? Whatever is inside that. P is equal to plus or minus root Q, plus or minus root 13. So it's not, I mean, you don't have tables available with you at grade 8. So you don't have to like compute the value of root 13 and so on. Just, I mean, you don't have to further break it down, I'm saying. See now, what is going to be root 13? Look at root 9, root 13, just for you to understand. See, root 9 is 3, root 16 is 4, and root 13 is between these two. So it's something 3 point something, obviously less than 4, isn't it? So you don't need to know the precise value, just leave the answer in terms of plus or minus root 13. So I'll just go to the next slide. Moving on. Let's take the same data again, because we need to compute the other result, isn't it? given a square plus 1 by a square is 11. And the question is a minus 1 by a is question mark. So a minus 1 by a, of the same thing I told you, you have to take a minus 1 by a the whole square, and that will be a square plus 1 by a square minus 2. So what is a minus 1 by a the whole square? A minus 1 by a the whole square. What is a square plus 1 by a square? 11. And 11 minus 2 is 9. So a minus 1 by a the whole square is 9. So related to the same thing what we did in the previous slide. P square is q. What is p? P is plus or minus root q. So a minus 1 by a the whole square is 9. So a minus a 1 by a is plus or minus root 9. Now root 9 is a fixed, standard value. No, we know what is root 9. It will be 3. So plus or minus 3 is the answer expected. So this is again another question from algebra. So we should, let's move on. Okay, so work on your identities, because there are only 4 or 5 identities that we have discussed. And from these, as I mentioned, only from these topics, we're going to get questions for the upcoming UT. Of course, for the finals, you're going to have more questions and more identities, and we're going to expand our horizon of algebra. So moving on to the next question of algebra. So it is perimeter of a triangle is 3y square minus 7y plus 4. So 3y square minus 7y plus 4. So two of its sides are 5y square plus 7y minus 9 and 7y minus 13. Find the third side. See, we can have different kinds of problems. If it's a triangle, it will have 3 sides. Okay, side 1, side 2, side 3. What do I mean by perimeter? Perimeter is the sum of all the 3 sides, isn't it? That is perimeter. Now, it's not that always you can be asked questions like this. You can twist and turn, isn't it? Maybe in class I've done it this way. So always be open to out-of-the-box questions. Rational thinking. It's important. If you become stereotypical and then you start just studying, or like you start memorizing maths, then it's of no use. And then you start blaming teachers that this is not taught and that is not taught. I've always told you in class, and this revision is done additionally from my end just to help you all. Okay. Now, how many of you are watching or not watching or using this, or how many of you are benefiting, it is regardless of that, thinking of my students have made it. So why am I saying this? Because in school, I've taught you that perimeter is sum of the 3 sides. Okay. Now, you know that when you add up all the 3 sides, you're going to get the perimeter. So I might ask you questions on 3 sides given, find the perimeter, or perimeter given 3 sides, 2 of the sides can be given. So, there are technically, if you look at this statement, there are 4 parameters, right? 4 entities, I would say. So any 3 will be provided, and you have to find the 4th one. So meaning, in this case, like in class, if you can look back, if you can relate to what I've taught in class, I've given you a question where I've given you all the 3 sides and find the perimeter, which is very straightforward, where you have to just sum up all the 3 sides, as in add up the 3 polynomials. It's basically an addition operation. But in this case, it is not the case. It's here, I've given you the perimeter. I've given you P. I've given you 2 sides. You have to find the 3rd side. So this will involve addition as well as subtraction. So first of all, 2 sides are given, isn't it? What is that? What are the 2 sides? Side 1 is 5y square plus 7y minus 9. And what is side 2? Side 2 is 7y minus 13. So 2 of the sides are given, and I'm going to add the 2 sides. So side 1 plus side 2, that is length of side 1. I'm going to get what? 5y square plus 7y minus 9 plus 7y minus 13. So what did I do here? I have added both the polynomials. Basically, sides are expressed in terms of polynomials. Not that I'll give you neat and clean numbers always. Here it's algebra, isn't it? So I can test you on polynomials. So now I'm just going to add them. 5y square, keep it as 5y square. And like terms can be added. 7y and one more 7y, giving me a 14y and minus 9 minus 13. So minus 9 minus 13, which will be minus, write it here, minus 22. Okay. So I'll go to the next slide. 5y square. So side 1 plus side 2 will be equal to, what is that? 5y square plus 14y minus 22. 5y square plus 14y minus 22. 5y square plus 14y minus 22 is the polynomial, trinomial. And what kind of a trinomial? Remember, I have taught you that the degree is 2, right? The highest power of the variable being 2. So it's a quadratic. The degree is 2. It's a quadratic. And there are 3 terms. So it's a trinomial. Okay. So that's about it. And now coming to the perimeter. Perimeter is 3y square minus 7y plus 4. So perimeter is 3y square minus 7y plus 4. 3y square minus 7y plus 3y square minus 7y plus 4. So I want the third side. Okay. So we have side 1, side 2, side 3. From the perimeter, you take away the sum of the two sides. Isn't it? You take away 1 and 2, you'll be getting side 3. Perimeter minus sum of two sides. So perimeter is given. Sum of two sides is, I have it here. See, I put it in a box here. I've added side 1 and side 2, isn't it? So from the perimeter, it will be 3y square minus 7y plus 4. Okay. So from that, from 3y square minus 7y plus 3y square minus 7y plus 4. From this, I have to subtract sum of the sides. What is the sum of the sides? 5y square plus 14y minus 22. So now it is, so in this sum, we have seen a case of addition and subtraction. It is simple, but if you understand the logic, minus 5y square. Now, because there is a minus outside, you have to change the signs of the terms inside the brackets when you take them out. So plus becomes minus, it comes out, and minus becomes plus 22 here. So now we will apply the operation of adding the like terms. 3y and minus 5y square is minus 2y square. Minus 7y and minus 14y is minus 21y. 3 minus 5 is minus 2. Minus 7 minus 14 is minus 21. Plus 4 plus 22 is 26. This is again a trinomial, and this is the final answer. I have just subtracted the sum from the perimeter. Okay. From the perimeter, take away the sum of the two sides. So this is what you will land up with. Okay. So this is as far as the algebra part is concerned. I hope the explanation has been helpful.